Okay guys, lesson 2.1, linear and quadratic functions and modeling. So as I said, what's up there on the board right now goes with, I think, pretty much the front and back of the first page of notes. I'm not sure we're going to get through all of that today, to be honest though. So that assignment is probably looking at being due on Wednesday. This is all the linear stuff. Then probably Wednesday we'll start looking at the quadratic stuff. So before we go into there though, let's review what it means to be a polynomial function. Does that word ring any bells from algebra? Okay. Whether you know what it is a whole different story, right? I'm not saying you have to know what it is. I'm just, the word should ring a bell at least. Polynomial. That's, okay, there's a chart. There's a chart here. Okay, so any function that is a sum or difference of x values having whole number powers and real number coefficients. So for instance, 2x squared plus 3x plus 5. That's a polynomial. Okay? It is the sum or difference, so it's terms that are added and subtracted together. Whole number powers, meaning you can't have in an exponent, you can't have a fraction and you can't have a negative. So whole number powers, real number coefficients, no imaginaries. Okay? That's what we are looking at right now. Okay, those are polynomials. When we talk about, does it come up here or does it come up, it might come up in the next lesson more. But when we talk about just one term in a polynomial, do you remember what one term is? Begins with M, monomial. Yeah, you started to say, I thought you were going to go all the way with it, but, okay. So, sum and difference, whole number powers, real number coefficients. Now, and we did have, Shiley said something about a chart, right? We had monomial, 2 terms was binomial, 3 terms was trinomial, and then past that it was just polynomial with blank terms. Okay, so this is familiar. Now, we're going to go, as we look at those, similar, but ours is going to be based on the highest power instead of how many terms. So, first of all, we have something called the zero function. Okay, the zero function is specifically the function f of x equals 0. Now, what is f of x the same as? That's the same thing as saying y equals, right? So on any of these, that is the same thing as saying y equals. But if it's something called the zero function, it's just y equals 0. Which y equals 0 is what? So horizontal line, specifically what horizontal line is if it's y equals 0. It's the x-axis, right? It's that horizontal line that is the x-axis. When we talk about degree, it's undefined. And leading coefficient, which would be the number that starts it, is just 0 because the only number there is 0. A constant function. A constant function is where you have f of x or y equals a, where a is some number other than 0. So that could be y equals 1, y equals 3, y equals negative 5, whatever it is. That has a degree of 0 because this is x to what power right after that? If there's no x, it's x to the 0 power. So that means it has degree 0. The leading coefficient, what does it start with? A. The number out front is A. Okay? Linear function. It says f of x equals ax plus b. We'll think y equals ax plus b. What is this essentially? Slope-intercept form, y equals mx plus b. Okay, this is a linear function though. What is the highest power? The highest power on the x is 1. What's the lead coefficient? The number in front of that x. Okay. Quadratic means the highest power is 2. Don't think quad as in 4. Think quadratic as in quadratic equation here. Solves our x squared equations. Highest power is 2. Again, the leading coefficient is always a because that's what's right in front of that highest power. Cubic means the highest power is 3. Okay. Again, leading coefficient. that's as far as this book goes. I mean, we could go 4, which is quartic, 5, which is quintic, some of those, but that's as far as this book lists right here, at least. Okay? So, the question we want to look at on example 1. Which of the following are polynomials? If it's a polynomial, I'm going to ask you that you state the degree and the leading coefficient. If it's not a polynomial, I want you to be able to tell me why it's not. And that goes back up to the idea that if it's a polynomial, it's a sum and difference of x values with whole number powers and real number coefficients. So, thoughts on example A. F of x equals 4x cubed minus 5x minus 1/2. So first question, is it a polynomial? Yes or no? He says yes with a question in his voice.
The only reason I see that it wouldn't be possibly, because I'm not sure if you think it is that it doesn't follow like the order like x to the third x squared x.
Okay, so can, in other words, I guess Ross is kind of asking, can it still be a polynomial even though it doesn't have an x squared term? Okay, and keep in mind, it could have an x squared term because we could throw in a 0x squared there. Okay, so polynomial is not going to have all of them. It's the sum and difference, yes. It's things being added and subtracted together. Whole number powers, in other words, we have x to the third, x to the first, and after the 1/2 would technically be an x to the 0 if you want. And real number coefficients. Any imaginaries? No. So yes, this is an example of a polynomial. If it's an example of a polynomial, we want to talk about the degree and the lead coefficient. What degree would this be? Third degree, what is the name for that up above? Okay, so it's degree 3. It is a cubic. I can't remember which way the book asked, what the book asked specifically. What's my lead coefficient? 4, because it is the coefficient on the cubic term, right?
Technically, if I were to remove that, it's the one with the largest.
Yes. Yep. The lead coefficient is the one on the largest power. Now keep in mind, they could be out of order. So you always have to look and search for that highest power. Okay, B. G of x equals 6x to the negative 4th plus 7th. Plus 7th? Plus 7. Is it a polynomial? No. If you're going to say no, you have to give me a reason. Okay. The 4 is negative. And what did it say about powers? Whole numbers. And what is a whole number defined as? It's positives, right? Non-negatives. So whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. So is this a polynomial? And the answer is no. And my reason? The power is not a whole number. In other words, a power cannot be a negative. See when you're ready. H of x equals the square root of 9x to the 4th plus 16x squared. What? Can we simplify? We could, okay, so if we're talking individual terms, there is a square root of 9x to the 4th that could be simplified. There is a square root of 16x squared that could be simplified. But can we take the square root of a sum?
But you're saying it like that.
Valid point. Okay, so think for a side moment. the square root of 9x to the fourth would be 3x squared. The square root of 16x squared would be 4x. So if you're saying that's the square root, when I square this, it needs to equal 9x to the fourth plus 16x squared. Does this expression equal this expression? No, because you would have to FOIL. So this is me taking individual square roots. And so if you want to argue that the square root of this is this, then the reverse has to be true, that I have to be able to take this and square it and get back to this. But this would have to FOIL. And when you FOIL this, you would end up with a middle term. Are we all okay on that? But if I FOILed 3x squared plus 4x, I am going to have 9x to the fourth, but I'm also going to have 12x cubed, so 24x cubed plus 16x squared. So there's your proof of why we can't take that square root. Does that help a little bit? Because you guys, every time we do something like this, you guys want to take these square roots. And the key to remember is we can't take a square root of a sum or a difference. Okay? Unless it factors into two identical parentheses, which that one does not. Okay? So, with that in mind, is this a polynomial?
No, because it was square root, and that's more than just subtraction.
Okay. So if it's a polynomial, it's supposed to be the sum and difference of x values. He said it's more than the sum or difference of x values, isn't it? It's the square root of the sum or difference of x values. Okay, so I agree, it's not. The other thing is, how do you write the square root as a power? Do you remember how to write a square root as a power? Yep, power of 1/2. Because this index, a square root, has an index, that little number in the root or whatever, has an index of 2. And so this would be to the power of 1/2. But when we talk about the power of 1/2, it's not a whole number. Hi, Shelby. Sorry, I just looked over here because I was trying to figure out what I was hearing. If you're interested in joining us, we are in lesson 2.1 notes, is where we just started off today. Okay? Okay. So, polynomial? No, it's not a polynomial. And essentially it all comes down to the square root, doesn't it? So, overall, you can talk about how the power is not a whole number, okay? Because remember, our powers have to be whole numbers, and 1/2 is not a whole number. So essentially, it's part of the power issue.
So can there be a polynomial with a square root?
Just a second, let me finish writing, and then I'll answer that. Okay, so can there be a polynomial with a square root in it? And only if that square root can simplify down to something acceptable. Okay, so like if you have the square root of 16, just the square root of 16, that becomes 4, and that's okay, yes? If you have the square root of x to the 6th, the square root of x to the 6th would simplify down to x to the 3rd. So that could simplify down. So that, in its simplified form, it would exist as a polynomial.
So you're basically saying if there were two radicals, so if there were two square roots, can then there be...
If this was the square root of 9x to the 4th in square root plus a separate square root, then it could simplify down to a polynomial, and then we could argue that it would be a polynomial.
That makes sense.
Does that answer?
They know that we want complicated to find the other two.
Huh?
Would that just make it, like, say that we did have one of those, it would just be harder to find the degree and the OC.
Right, you'd have to simplify it down before you could find a degree or leading coefficient. Okay. D. K of x equals 15x minus 2x to the fourth. Polynomial? Yes? It's the sum or difference of x values, whole number powers, real number coefficients. Okay. You know, you're just saying yes because you feel like it's about time we have another yes. Okay, but the thing is, you said yes. So now, that means you have to be able to answer what is the degree and what is the lead coefficient. Degree is 4. Why is the degree 4? It's the highest power. Very good. So, if the degree is 4, what's that say about my lead coefficient? It's -2 because the lead coefficient comes from the term that has the highest power. Okay, so because the degree is 4, we search for the highest power, right? Highest power is 4. And then from there, the lead coefficient is the coefficient of that term. And so, and it basically comes down to, could you rewrite k of x in the order it's in? If it makes you happier, you could rewrite this and say that this is -2x to the fourth plus 15x. You could do that if that would make life better for you. Okay. Questions here? Okay. Moving along then. Linear functions. Okay, you guys know linear functions. You've been working with these since Algebra 1. A polynomial of degree 1 with a leading coefficient equal to the slope. We talked about this earlier, didn't we? When I said ax plus b, we talked about how that is just like saying y equals mx plus b. So when we talk about a linear function of that ax plus b form, it's the same thing as saying y equals mx plus b. Okay. Sorry, I'm reading my comment here and it's not making sense to me. The constant function, okay, so if we just, as a side note here, the constant function, which if you think about the constant function, which is the y equals a from up above, the constant function is the graph of a horizontal line, okay? So that does, to an extent, fall into linear functions. Side note though, vertical lines are not functions because they do not pass, and this should say, that's where I'm thrown off. Vertical line test. That's where I was not making sense to myself. Okay. Vertical lines are not functions because they do not pass the vertical line test. So there, if we go into something like x equals a number, that's a vertical line, can't pass the vertical line test. I'm back, okay? So all of that to go and say linear functions are not going to be your horizontal lines, okay? Even though we think of that being a linear function. Linear functions are specifically your slant lines, ones that have a slope of something other than 0, okay? Now, okay, right here, guys, example 2. Write an equation for the linear function f of x such that f of -1 equals 2 and f of 3 equals -2. You're not going to like me for saying this, but this is an Algebra 1 problem. It doesn't look like it, but I promise it is. So all of that, what I'm saying is you know how to do this. You just have to get it so you understand how to do it. You know how to do this. First of all, we're writing an equation for the linear function, f of x. What do you think of for linear function? Y equals mx plus b. So I think we can all agree. You guys have all had practice at writing y equals mx plus b functions, yes? What? Okay, so what Jace is trying to point out here is that if this is f of x equals a value, 3 is an x value, correct? When you put x into this equation, what do we get out? A y value. So when it says f of 3 equals negative 2, what are they really giving me there? Not the slope and intercept right there. They're giving you an xy, so they're giving you an ordered pair that is 3, negative 2. What else are they giving me then? Another ordered pair. Another ordered pair, which is negative 1, comma 2. Now, if I ask you to write an equation using the ordered pairs, negative 1, comma 2, and 3, comma negative 2, are we sounding a little bit more familiar? Does that sound a little Algebra 1-ish to you? If Algebra 1-ish is such a thing? Okay, so let me put my ordered pairs over here. And then, what do we need first to write our line y equals mx plus b? We need a slope. How do we find slope?
y1 minus y2 over x1 minus x2.
There we go. It's coming back to us. y2 minus y1 over x2 minus x1. That's what you were officially taught back in Algebra 1, yes? Maybe. I don't know. Did you guys learn slope in pre-algebra maybe?
Yeah, we did.
Okay. That's possible. I could understand that. Now, when I teach this, I don't necessarily throw in the 2's and the 1's. I basically just say y minus y over x minus x at this point in my life, because if you've made it this far, you understand whichever ordered pair you start with on top, you start with on bottom. Okay? So, y minus y, what are we doing here, guys? What order do you want?
I went negative 2 minus 2.
Okay. He did negative 2 minus 2. I'll be honest, that's the opposite that I would do, because I would start with the positive. But it's not going to matter. So if he says negative 2 minus 2 on top, because those are my y's, what must go on bottom? What I'm going to write as 3 minus negative 1. Which now you'd start with the positive, so it's all good. Okay? Realizing you could have reversed both of these, yes. It'll all work out the same. Negative 2 minus 2, negative 4, 3 minus negative 1, as was said, 3 plus 1 is 4, negative 4 over 4, negative 1. What is that? That's our slope. See, you knew how to do that, didn't you? Okay? Okay. We need an intercept. I'm trying to think when I teach this. I see what I have written there in my notes. Okay, thoughts? We got to find B.
Can't we just pick an ordered pair and plug it all in?
Okay, so can we use one of our ordered pairs and our slope and plug it in and find B? Is that what I taught in Algebra 2?
Yeah.
I have a feeling, well, we could have done it this way, I guess. I could have already reviewed it earlier this year. There's two different ways to do this, okay? And in Algebra 1, this is probably more what you learned. I may throw the other one up on the board here behind me in a moment. But if we use y equals mx plus b, this slope, and what ordered pair do you want to use? Does it matter? Well, I just circled the other one. Now, here. Hello, meet me in the end. You guys can do algebra. You can do this as basic here. Plug your y value in for y. So I'm choosing to use -2 equals m. I'm going to plug my m value in, which is -1, times x. My x value is 3, plus b. So -2 equals, for me, it's -3 plus b. And then I'm going to have to add 3 over. And I get b as 1. If you use the other ordered pair, you should be at the same point as me, right? And so what is my equation for this linear function? Y equals what? Okay, -1x plus 1. If I want to get specific, it said to write an equation for the linear function f of x. So this could also be written as f of x equals -x plus 1. In my brain, those are equivalent. It all depends on how they ask the question. Okay? Side note here. Do you guys remember something called point slope form? Okay. And I'll be honest, I'll probably use this sum coming up. Let's redo this problem real quick using point slope form. Point slope form is incredibly helpful. In calculus, I use more point slope form than I do slope intercept form. And honestly, to do this problem, I think it's a slight bit easier. Personal opinion. You still have to find the slope first, correct? So you still have to do this step over here of finding slope and getting -1. You still have to pick one of your ordered pairs. And so then we're filling in y minus, if I use my same ordered pair, my y coordinate is -2 equals m. What's my m? -1. And then it's x minus, what's my x coordinate? 3. And then from here, it's just some cleaning this up. What do you know about y minus -2?
Y plus 2.
That's y plus 2. What do you do with the -1? Distribute. So it becomes -x and then plus 3. How do you get y by itself? If it's y plus 2, subtract 2. Y equals -x plus 1. Same answer? You can't see, but you have it written down there. Okay? I personally like that one a little bit better. Maybe I should have taught that one first and then reviewed the other one. I might have done myself an injustice there, but they both work. If you're told in this stage of the game to write an equation for the linear function, it's your choice how you find it. I'm not going to grade, okay, did you use y equals mx plus b to find b, or did you do the point slope and y minus y equals m times x minus x? Okay? So, your choice there, I just wanted to kind of show both, if you don't mind. Okay, I'll let you guys get that down. Questions on that section then? Okay, sorry, that's the, what time do we get out of here? I got to gauge my time. Okay. We'll see what we can do get done with average rate of change there. Although, in all honesty, average rate of change, well, I'll let you guys make the deduction here, but In my mind, average rate of change is like something we've already done today. Okay, did you guys get what you needed here? I saw several people copying, that's why I was waiting, so I didn't want to.
I like the other way. I don't know why. Yeah, no,
The original way or the new way?
No, the first one.
The first one I did? Okay, and that's
I just do. I like white also.
that's fine.
When the point slope, I like keeps it, those are stuff easy to come out of line.
And I feel like with the advantage of the point slope form is you don't have to go back and think, okay, now I gotta go back and plug in B. Like you get to the end and you're done. So, okay, average rate of change. The slope. We've already talked slope today, right? That's essentially what average rate of change is, guys. The slope of a linear function, m equals y2 minus y1 over x2 minus x1, characterizes something called the function's rate of change. So when we're talking about rate of change, we're essentially talking about slope, at least in terms of linear functions. A linear function's rate of change, the m, is constant. Because as you look at a linear function, a line, that rate of change is constant because that rate of change of how you go up that line is not changing. Okay, you're not going around a curve, you're going up or down a line, and so that rate of change is constant. In other words, the slope. All functions have rate of changes based on different values for x. There is an average rate of change for a function, however, given an interval. So, what we're going to look at when we talk about average rate of change here is, okay, what if it's nonlinear? If it's linear, that rate of change is the same throughout the whole function. What if you've got a parabola? Do you have the same slope all the way around the parabola? Parabola being that U-shaped curve, right? And it's not, because it's changing. Some places it's steeper, some places it's flatter, decreasing, increasing, those kind of things. So, we can find an average rate of change for an interval. And that's what we're looking at here. The average rate of change of a function, y equals f of x, between x equals a to x equals b. So that's your interval, where a and b are not the same. Because if a and b are the same, there's no interval. Can be written in interval notation from a to b. And this is what we're going to use for average rate of change. Okay? So when we talk about average rate of change, we're using this formula here, based on the interval a to b. F of b minus f of a over b minus a. What are b and a? Those are what kind of values? The x values, yes? What are f of a and f of b then? Those are the y values. Do you remember from the front side where I said, okay, we're writing a linear function. You guys looked at me and said, we are. This is algebra 1. But then we wrote those as ordered pairs, and it was doable. Okay, same thing here. The denominator are your x values. The numerator are your y values. In other words, we're finding slope. Y minus y over x minus x. Now, the difference is we might have to find a little bit first. So, let's at least get through example A. Compute the average rate of change for f of x equals x squared, so parabola, but specifically on the interval from x equals negative 2 to x equals 0. These x values are going to be what? These are my a and b. Okay, so dub one of them a, and dub one of them b. To be honest, it doesn't matter. It'll all work out the same in the end. I picked my negative 2 to be a, my 0 to be b. Now, besides knowing a and b, what else do I have to know? F of b and f of a, which means I'm going to have to find f of negative 2 and f of 0. What does f of negative 2 mean? Replace x with negative 2. The equation is x squared, so that means I'm really doing negative 2 squared, which is 4. And then when you do f of 0, That means you're doing 0 squared, which is 0. So we just found f of negative 2 to be 4, and f of 0 to be 0, correct? Okay. Average rate of change formula is right up above. F of b minus f of a over b minus a. Okay, computer's still on fall break. Hold on. Okay, okay, computer's back. 0 minus negative 2. 0 minus 4 is negative 4. 0 minus negative 2 is plus 2. Negative 4 over 2, negative 2. The average rate of change on that section of the parabola is negative 2. And, okay, that is where we will stop. The homework should be listed in Skyward. It's not due tomorrow because I still want to do a little bit more with average rate of change and talk about linear correlation, which make sure you have your calculators tomorrow because we'll talk about doing linear regression on the calculators. Okay?